right, so we have a tank with these dimensions here, and they're all in different units. So that's gonna mean we've got to convert them all to one unit. We'll do that to the base. We can multiply them and get the volume. The mass is given to us right there in scientific notation, and is asking us to calculate the density. Now, pretty straightforward stuff. And the units of those densities we're going to have to convert. It's just going to be a pain in the butt because there's so many steps to this. But it's a straightforward problem in that it wants us to solve for density, and it gives us mass, and we can calculate volume. All right, so let's just chip away at this here. First thing I'll do, there's many ways you can probably do this, and just the important thing is we get the same answer. All right, I'm going to convert all these units of length into the same unit, and I'll just choose the base unit right there, meters. All right, so 28.6 centimeters, we can turn that into meters by using the conversion factor. 100 centimeters is equal to 1 meter. That'll cancel out the centimeters, and since you're dividing by 100, just move that decimal over 2 spots, and you got 0.286 meters. All right, there's that one side in meters. Let's do the other one. 73.0 millimeters. All right, we can turn millimeters into the base meters. All right, because 1,000 millimeters in 1 meter, so that's dividing by 1,000. That's 1, 2, 3. So that's going to be 0.0730. That last zero is significant, although it's not going to matter because this number next here only has 2 sig figs. And the last side of this tank is given to us in meters, so nothing to do other than just, there it is. I'm sorry, that's not millimeters. All right, I'm trying to do this fast and kind of mess it up here. All right, that's meters, the second side. What is that noise? All right, so now I'm going to multiply these 3 sides and get the volume. Let's get a calculator out. 0.286 times 0.037, sorry, do that again, 0.286 times 0.073 times 0.72. Okay, so that is going to be 0.01503 and 216. I'm not going to write all those digits. We're not going to need it. But you shouldn't round here. You should round at the very end when you have to, because all we're doing is multiplying and dividing. All right, and that's going to be meters cubed, because we just did meters times meters times meters. Now, I'm going to just change that right to liters, because that's what we're going to have to do at some point. I'm already doing volume. I'm going to finish it now. You could have gotten density and done another conversion factor later. All right, so I got 0.01503 cubic meters, and I'm going to turn that into liters. Now, if you don't know that a liter is equal to a cubic decimeter, then you're going to have to do some more steps. So, I'll do the long way, because I'm not going to assume you know that. So we can go from, here's the big picture. We're cubic meters, and we can take that to centimeters cubed, and then we can take that to milliliters, and then we can take that to liters. All right, now if you knew, the faster way would be take that to cubic meters to cubic decimeters, and then that's going to be equivalent to liters. That's a little faster. All right, so I changed my mind. I'm just going to go do the faster way, and then you can do the longer way if you want, and we'll still end up with the same answer. All right, so I want to change cubic meters to decimeters, and because I know if I can do that, cubic decimeters is equal to 1 liter. All right, now 1 meter is equal to 10 decimeters. 10 deci means 10 times smaller. Now when we cube this, we've got to cube the entire conversion factor, not just the units. All right, so in fact, let me write it this way. Just cube there, cube there. All right, so you can see this is going to cancel out. This is going to cancel out. Let me distribute that exponent over here to the 10 as well. That's 10 times 10 times 10. All right. So now you see we're just left with liters, which is what we're trying to do. All right. So everything else is ones. So we'll just do 1 or 0.01503 times 10 to the 10 to the 3 liters. All right, and we can just move this decimal over 3 times, 1, 2, 3, and just rewrite that in a little more better way, 15.03 liters. So there's my volume. Now, we did all that to get the volume. Now let's get the mass. Mass is going to be a little easier. I'm going to change the color up here because it's just grams to kilograms. Right, there it is, 1.38 times 10 to the 4. 1.38 times 10 to the 4 grams. Turn that into kilograms. There's 1,000 grams in 1 kilogram, because kilo means 1,000 times bigger. And since we're dividing by 1,000, we can just lower that down 3, and our answer will be 1.38 times 10 kilograms. And we can rewrite that as 13.8 kilograms, because 1.38 times 10 is 13.8. All right, so now we have our mass in the desired unit, our volume in the desired unit, and finally we can just put them, divide one. All right, so finally we can do density, mass or volume, and that's going to be 13.8 kilograms over 15.03 liters. Punch, punch. 13.8 divided by 15.03. All right, final answer is 0.92, because 1 and then peak 1 after is an 8. That's going to round your last digit up to a 2. All right, so 0.92 kilograms per liter. Whew, that was a long problem. All right, there's 2 sig figs because remember back up here, this measurement only has 2. So the rest have 3, but our answer can't be better than the measurement with the least number of sig figs when you're multiplying or dividing. If you want to write this in scientific notation, it would be 9.2 times 10 to the negative 1 kilograms, and you can do that if you want. That's good too. That's good.